a second. Well, good morning, everyone. I'm John Houston, I'm Chairman of Solastor Australia. Very pleased that you can all make it today. I should start by recognising the traditional owners of the land, the Ghana people, and pay my respects to the elders past and present. I say personally how much I look forward to the day where we give them appropriate recognition in our Constitution, which has got bipartisan support and not that far away. Today is actually all about bipartisan support, so I'm very pleased that we have a range of people here. Jay Weswell, of course, the Premier, and Greg Hunt, Minister for the Environment, Mark Butler, the Shadow Minister for the Environment, Ian Hunter, Minister for Energy, Dan Van Holst Pelican, the local member, who have I forgotten? Oh yes, Rowan Drew Ramsey, who I must acknowledge has made a significant contribution down the Port Augusta area to building community support, so we thank you very much for that. It's my pleasure today to introduce you to the concept of Solastor and what it can do. The Australian economy is basically, of course, into two transitions. One from a resource boom-based, construction-based economy to whatever. And the other one is, of course, a transition to a low-carbon society. These are very significant transitions, and they're very challenging. And we think, from the point of view of sustainable solutions in these areas, technology is fundamentally important to both. It's a technological revolution that I think this country needs to actually restructure our industrial base, our society's base, and move us forward. So from our point of view, we see Solastor as a game changer, both for solar and for renewables as a whole. Solastor can produce 24/7 baseload power at the lowest price in the world. It's a very simple system. It can also be used as a peak supplier. So one of the problems, of course, in South Australia has been the intermittent nature of wind, which tends to blow at night, and sun, which only shines for part of the day. And so the disruption, the morning peak and the evening peak is very difficult. It can be very expensive for the community. So we can actually deal with that through this technology as well. We think it's the world's best technology. It certainly produces 24/7 power at the lowest price anywhere in the world. And I think the way to introduce this is to just run a brief video so you get a sense of it before we say any more about it.
A new day dawns in a solar energy plant that can produce power 24 hours a day. A weather station detects the sun's rays, and the plant's control system directs the specially curved toroidal tracking mirrors, called heliostats, to focus the sun's rays up into the solar thermal receivers, or STR, which are mounted on 24-meter high towers. An STR contains 10 tons of graphite, and as the morning progresses, the graphite is heated by the sun to a maximum of 800 degrees centigrade. The accuracy of the heliostats is continuously monitored by a camera at the base of the tower, and if required, recalibrated by the plant's computerized control system to correct any tracking errors. To produce electricity, purified water is pumped from a holding tank to the STRs. Within the STRs, the water passes through a series of pipes embedded in the graphite called heat exchangers. The hot graphite converts the water into superheated steam. The steam is then directed to a turbine and electricity generated. After it leaves the turbine, the steam is cooled, and the resulting water is returned to the holding tank to be recycled. As the sun loses its heating capacity, the STR are sealed. Once an STR has cooled, the control systems automatically remove it from the system and bring online a new hot one, thus maintaining the flow of steam. The Solastor system, having produced power during daylight hours, will continue to produce that power during the night. When the sun rises the next day, it will reheat those STRs that have cooled during the night. Meanwhile, other STRs heated the previous day and not used during the night will continue to provide steam to the turbine and generate a constant flow of electricity. The Solastor system is modular. The more energy you need, the more STRs you add. Environmentally friendly, low cost, guaranteed 24-hour solar power. Solastor.
Thank you very much. I think that gives you a sense of what we're on about. Our plan is to build our first stage plant, a $1.2 billion project, 110 megawatt in winter and 170 megawatt in summer, near Port Augusta. We're quite advanced in terms of discussions. There's access to the land, finance and approvals, so we're enthusiastic to just get started. Before I say any more about it, can I invite Premier Jay Weatherall to speak? Thank you.
Well, thank you, John, and my federal and state colleagues, ladies and gentlemen. Well, South Australia has been blessed with rich and abundant natural resources of solar and wind energy. And we take seriously our leadership role in this area of renewable energy. We have something like 41% of our energy is produced through renewable resources. And South Australia has an ambition to create really the engine room for renewable energy for the nation, to assist the nation to meet its renewable energy targets, but to assist our state to actually take advantage of the opportunities of producing low-cost, high-sustainability energy. The industries that will swing off this power source create the opportunity for us to transform our economy. They also create the opportunity for us to get involved in high-tech manufacturing, and that's what we're seeing today. An interesting piece of technology which will allow South Australia to take this leadership role in the nation. No need to look at the systems involved here, to look at the opportunities of the production of heliostats, the opportunities for the construction of the steel frames, the opportunities for the mining of graphite to provide the blocks necessary for the technology to make this work. All of these are industries that swing off this one project. So we're incredibly excited about what this means. But there's another element that we need to ensure that these projects are successful. And that is for us to have a 21st century energy market and 21st century rules for an energy market that permits us to realise these ambitions. For the last decade, we've had too much policy confusion, and it's wonderful that we've got two representatives from our national leadership parties, the Liberal Party and the Labor Party, here expressing bipartisan support for a project of this sort. This is absolutely crucial if we're going to get the sort of investments that we need for the future. We have an energy market which does not support renewable energy. We have an energy market which doesn't support the connections which assist us to play our renewable energy into the rest of the market. In fact, we don't have a national energy market. We have a series of state energy markets that are clipped together with poorly interconnected systems. If we're to realise our ambitions to play into the Australian energy market, our wonderful renewable resources, we need a modern energy market, and I hope that that's something that will emerge at the end of this election campaign. We're certainly fighting hard for it. It's one of the key issues we put on the table for advancing this agenda for our state. But also, I want to conclude by talking about this at a local level. We have two local members of Parliament represented here at a federal level, Mr Dan Van Hospelkamp and also our federal member, Ryan Ramsey. This represents an incredibly important investment for the Upper Spencer Gulf, a place which is really feeling the effects of this move to a low-carbon economy. So the transition that's going on in the South Australian economy is exciting, but it's also unnerving for the people that are directly affected by it. So we do need a transition from this old economy to a new economy, from a high carbon emission economy to a low carbon economy. And at the same time, we need to make sure that the workers who are working in that old economy get opportunities and jobs in the new economy. And that's what's most exciting about this. The idea, John, that you can get cracking on this now and providing work for those workers that are wondering about what their future is a very exciting thing, and I'm sure that the local members are very grateful that you're putting this proposition forward. You'll have the full support of the South Australian Government, and I know you'll have strong support from both Federal Labor and Federal Liberal Party. So congratulations for bringing us to this day. Thank you.
Well, thanks very much, Jay. I mean, I had the privilege at the end of last year of working on the task force that Jay set up with Anna Skovic and Frank Jotzer to look at the transition to the South Australian economy through to 2050, whether you could reasonably support zero net emissions as an objective by 2050. In that report, of course, we came to the view that somewhere in the 2030s you could be 100% renewable. We did extend that recommendation to say that if we don't have an emissions trading scheme in this country, maybe you could sell those permits into the California scheme, pull billions of dollars back, but I won't dwell on that. I'll just take the opportunity to call on my friend here, the Honourable Greg Hunt, Minister for the Environment. Thank you very much for coming. Greg, would you like to say a few words?
Thanks very much to John and to Jay, to my counterpart Mark Butler, to Ian Hunter, to Dan, and also especially to Ryan Ramsey, who has been such an advocate for Port Augusta and more generally for the communities of the Gulf. So there's a phrase from T.E. Lawrence, who wrote The Seven Pillars of Wisdom, but was perhaps better known as Lawrence of Arabia. And he said that the dreamers of the night may dream their dreams, but the dreamers of the day are dangerous men and women, for with open eyes they help to shape and mould the world to come. In the nicest possible way, John, you and your colleagues are dangerous men and women. You imagine the future, but more than that, the people in this room and all of those associated with Solastor are helping to bring the future. The great challenge for the world is to reduce emissions, but maintain prosperity and indeed advance prosperity. And what Solastor does with this graphite technology is really to address two of the great tasks that we face as a nation, and more particularly we face as a globe. And so those two tasks are, how do we ensure that we get 24-hour stable renewable energy in dealing with an electricity market, as Jay points out. We have to have a national approach, and in doing that we have to make sure that we are generating electricity when we need it. And the key to that is the ability to provide storage, and what this technology does is provide that approach to storage. In the same way, we're looking at Tasmania and the relationship between wind and the hydro resources there, and using the two to counterbalance and offset each other. That's how Tasmania can really contribute to the system. But South Australia, in our view, should be a solar state. South Australia should be a solar state, and we want that to be the case, and this technology provides that pathway. It also provides a pathway to dramatically lower cost, more competitive renewables. And when you bring those two things together, that is a very exciting pathway. So I know, John, that you have already indicated that you would like to have talks with, and we will facilitate talks with the Clean Energy Finance Corporation and the Clean Energy Innovation Fund. I have already spoken with the chairs of both of those bodies about this technology and commended it. They will make decisions on the basis of due diligence, but when we set out the $1 billion Clean Energy Innovation Fund, the Prime Minister singled out one particular project, and Rowan played a very important role in this, and that was Port Augusta Solar. And again on Saturday he endorsed this technology and this site and this project. It's an incredible opportunity for South Australia. Similarly, we want Adelaide to be a solar city, and so I'm delighted to complement the work today, John, with an announcement of $466,000 for local solar towns and community projects in the north of Adelaide and the south of Adelaide. I think $266,000 in the north, including Port Adelaide, Macon and Wakefield, and $200,000 in the south, including projects such as supporting the Spastic Society and Girl Guides with local community solar. So the big picture is national solar, as Jay says. The smaller side is to make sure that communities are also able to participate. But it's a great project. As a Commonwealth, we would be delighted to be supportive, and we will facilitate the work with the Clean Energy Finance Corporation and the Clean Energy Innovation Fund. But congratulations to everybody.
Thanks very much, Greg. I'm sure everyone's written those commitments down. No, very much appreciated. Mark Butler, the Shadow Minister for the Environment. I'll give you the floor now, Mark. Thank you.
Well, thank you, John. Thank you, Premier, for being here today, and Greg for coming to South Australia, and to my other parliamentary colleagues, state and federal. I also want to acknowledge, though, the activists from Port Augusta who've been driving this campaign. Gary, who chairs, I think, Repower Port Augusta, a former worker of Alinta's up in Port Augusta. Dan Spencer from the AYCC, who's been such a strong partner for the community in this campaign. And really, without them, with the support of Rowan and Dan as local members, we wouldn't be talking about concentrated solar thermal within the prism of Port Augusta. We would be talking about it more in the abstract. So congratulations to you. I know you are figureheads for a much broader community campaign, but it really is, I think, now starting to reap dividends, I hope, at the end of a period that's been very, very difficult for your community. So congratulations, and thank you for the work that you've been doing. It's great to have John Hewson here as well. John and I have spoken together at a number of conferences, as I'm sure Greg has as well, and he is quite the climate warrior. He is really someone who argues in a very convincing and detailed sense about the economic opportunities, but also the imperatives involved in decarbonisation. And I have been at many events where John has reminded us that Fightback actually included a very, very ambitious emissions reduction target. And I have to say that as a very young official campaigning against you in 1993, John, that eluded me. I was a little bit more focused on your plans for industrial relations and a range of other things, so I apologise for that. You have remained constant and consistent about the imperatives and opportunities that come from decarbonisation. It's also good to be here with Greg. There is much that divides us and our parties in climate change and energy policy, and in spite of the fact that I think at a professional and personal level we get on very well and have a constructive relationship, we do tend to find ourselves more often than not debating each other. And so in the middle of the longest election campaign in people's memory, for more than 50 years, it is great to be at an event talking about stuff that unites us. And we worked very hard, both of us, to get the renewable energy target back on track, to underpin a bipartisan renewed target last year of 33,000 gigawatt hours that will require a very substantial amount of building over the next few years, about 6,000 megawatts of building if we are to achieve that target. And in doing that, both of us came under pressure from the far left and the far right about tactics and broader strategy, and we did resist that. And I think in doing that, our parties were able to deliver or re-deliver investor confidence at the type we see crystallising today with Solastor. So it's great to be here with Greg, reinforcing the bipartisan commitment to delivering that 6,000 megawatts of build between now and 2020. But also both parties supporting concentrated solar thermal finally getting a foothold in Australia, because I think one of the disappointments over a period of several years of extraordinary development here in Australia, particularly here in South Australia, in wind and PV solar, both at a small and now utility scale, has been the failure of concentrated solar thermal to get a foothold here. We see it now getting that foothold in other countries, and it's more than beyond time that we start to land these projects here in Australia. And there is, as Greg has said, bipartisan commitment from the major parties to see that happen in Australia, and given the work that Port Augusta has done, it's difficult to see it happening anywhere before Port Augusta. We have some slight differences around financing arrangements. We still have a commitment to some grant funding for concentrated solar through ARENA. We support the Clean Energy Innovation Fund that Greg and Malcolm Turnbull announced a few weeks ago, but really, whether by hook or by crook, I think there is that didn't quite come out how I wanted it to. One way or the other. One way or the other. There is very strong support from the Port Augusta community into the National Parliament and everywhere in between, I think, for concentrated solar thermal, including through this great technology that Solastor has unveiled before us today, to become a reality in South Australia. Thank you very much.
Thank you very much for those comments, Mark. I mean, the temptation is now enormous for me to start an auction. I've got one bid, I've got another bid. I think we can work this into something that's quite significant. Yes, look, a lot of people in this room have contributed to us being here today, and I'm glad you mentioned the Repower South Australia, so Port Augusta program, and we have Steve Bloom here from the Solar Council, who is also president of the Storage Council, and I think that we've greatly supported the work that he's been doing, not only broadly in the terms of the debate, but now more recently focusing on community solar. Port Augusta, apart from the political pressure that's come from Repower Port Augusta and others, is a natural place for us to start this project, because, well, it's making the transition from a coal-fired power station, which is closed back on the 8th of May, to, we think, concentrated solar thermal. Secondly, of course, from our point of view, we worry about the intensity of the sun, what we call the DNI. It's about 6.5 at Port Augusta. It's ideal. There is a band, actually, that runs from Port Augusta along the East Coast grid all the way to Townsville, so we could actually roll these things out all the way along there, but the obvious place to start is Port Augusta. It has a port, and of course it has, as I said, access to the grid. So it's an obvious place for us to do this project, and it's great to have the community level support in that sense. I mean, the big constraint on wind and solar over the years has been their incapacity to have storage. When the sun shines, it's fine. When the wind blows, it's fine. But you need to be able to spread that out over the 24-hour period. That's the essence of this technology. It's Australian technology. The elements of it were originally developed by a power plant engineer who built a dirty black coal-fired power station in Lithgow, and couldn't understand why we did that. Why did we burn coal? And so he led him into a whole host of other activities. And the work that's been done beyond that to extend it has been very significant. We are just focusing on this original project. In the numbers that we've done, we are actually using ingredients supplied from offshore, from the Middle East in terms of the steel, and from Thailand, I think, in terms of the glass and so on. We don't want to raise expectations. We're saying that that's worth about 300 jobs in the construction phase and about 100 in the operation phase, although every time I see a press report, those numbers are getting elevated, so that's fine. Somebody's doing our job for us. But the possibility down the track of sourcing the steel in Australia, sourcing the glass in Australia, sourcing the graphite in Australia are very real. You can see 3 new industries sitting out there that spin off this. And a couple of our other businesses in terms of heat storage, batteries and pure natural graphite would actually add momentum to that. So I do think that this is a great opportunity for Australia as a whole. I'm very proud to be associated with this because it is Australian technology, it's world leading technology, and we can produce baseload solar 24/7 for around 12 cents a kilowatt hour, which is a fraction of what it would cost you to put a battery on a solar farm. It's going to triple the cost. Or molten salt, I think we've got 60% of the cost of molten salt. So we think we have the world's best technology at the lowest price. To finish, I'd just like to briefly introduce some of our team. The team behind this is a group of very experienced people who have done an enormous amount of work over the years in various sections of industry, both here in the region and internationally. Commissioned most of the biggest boilers and power stations, managed some of the biggest mine developments, and has very senior engineering roles in a number of activities. So I just briefly, if I could just get them to stand up. Lyle McLaughlin over here in the middle made a lot of money in transport. Now he's seen the light. He's going to put it into solar. And I think he's built a couple of, at least 2 major transport companies, starting with coal and moving on out of them. Steve Hollis next to him was I guess Chief Engineer in Main Post, Chief Engineer of the Snowy Mountains Engineering Corporation. No, CEO, sorry, of Snowy Mountains Engineering Corporation. Who else we got? Bruce Rankin over here. He has commissioned a whole lot of boilers and power stations all around Australia, Asia, the United States, UK and Europe. Yeah. So, I mean, we've got a very significant team. Shad Lindley, where's Shad? He's notorious for building all sorts of businesses over many years, some of them in this state and elsewhere. My colleague here, Phil Hall, he's a jack of all trades and master of most of them. He comes from a very diversified background, I guess, in architecture, construction, tourism. More recently, has spent about 15 years on this and related technologies. So I think they're a pretty significant team. Have I forgotten anyone? Jane at the back. She's organised all this and she does all our marketing and communications. I'd ask them all to come up because what I thought we might do is just open the floor for questions for a few minutes, just to see what issues that people might want to ask. And I think it's better that I spread the joy of those answers. So if you guys could just come up, I think that would be helpful. And we'll take questions. I mean, please don't feel inhibited. Yes,
John, it's a bit like a Dorothy Dixon because I know the answer. But I think it would be good if Steve was to explain the quantum leap in mirror efficiency to the group here. To me, this is one of the things that has really made this project go. And we haven't spoken about toroidal mirrors and the mechanisms you've set up to make it work. And I think that'd be very helpful.
Thanks, Rob. Excuse the froggy throat, but I'll do my best. The CSP systems all use mirrors reflecting the sun's energy up into a receiver of some sort. Those mirrors are extremely costly. So a measure of efficiency in that system is how much of the energy, sun's energy that falls on the glass mirrors actually finishes up in the target. That's the key measure. For high towers and whether they've got molten salt or not, they only get about 40% of the energy that actually falls on the mirrors, actually gets into the target. And the reason's a bit obvious when you see it. You've seen the pictures of those towers with the shining light. The target is on the outside. So a lot of the heat that actually goes in radiates back out again. That's one source of loss. And the other thing is that they generate air currents which go up past the targets and take a lot of the heat away. That results in the 40%. This system, as you can see here, these mirrors catch the energy and put it into a very, very tiny hole. So the receiver's actually on the inside. So it's not subject to a lot of re-radiation loss. It's not subject to a lot of convection loss, but more importantly, because it's a very, very tiny hole, we had to devise technology with mirrors that got all of the energy as much as possible into that hole. And the problem with the big mirrors that you see in other systems, whether they're flat or whether they're spherically curved, is that, like I said, they suffer from astigmatism. What that means is in the morning and the afternoon, the images of the sun that are projected at the target spread out. So the energy that doesn't go onto the target is lost. What we've got is what's called a toroidal mirror. What's a toroidal mirror? You get a donut and cut a slice off it. You see its curves one way, different radius the other way. Toroidal mirror is the same. It's got a different radius in the x-axis to the y-axis, like that way. So what ordinary mirrors do when they're tracking the sun is they go like that and they go like that. What a toroidal mirror does, it goes like that and it goes like, and it also rotates. And by rotating, because it's got those different radiuses, it adjusts the focal length and keeps the image in the hole all day. The effect of that is to increase the field efficiency up over 70%. So what does that mean in terms of cost? Well, I did say before that the cost of all of these mirrors is over 60% of the cost of the whole project. So by having almost double the efficiency, we've got half the amount of mirrors to collect the same amount of energy. And that's where the cost savings are. And that technology was all developed in Australia by people we've been associated with and from our research and development facilities located in sunny downtown Cooma.
The bottom line of all that is that originally they started with about 30% efficiency. It's about 72% efficiency now. I think that's very significant technological advance. Other questions? Yes?
John, is keeping the mirrors clean an issue? And secondly, with that much steam being generated, is there any future for the clean water system?
Yes. PV panels and or mirrors do collect dirt and they have to be cleaned every so often. The phenomenon you see with mirrors in all of these systems is that they start off at about 94% reflective. They get a bit of dirt on them, they drop down to just under 90%, and then they take a long time to get any dirt in that. So the way we structure the operating and maintenance contract is that we give the operator of the plant an incentive to keep the mirrors clean. And so he can operate the plant and it'll produce a certain amount of energy. He can get about another 5% out of the plant if he cleans his mirrors regularly. We leave that as an operational decision. But in practice, the plant we had at Lake Jellicoe and the one that's operating in China, they wash the mirrors about every 6 weeks. Except in the local coal-fired power station in China, belches black rubbish out all day. They've got to clean them a bit more frequently.
Okay.
And they stand vertically at the night time so that they don't get dew.
Steve, could you tell us the source of the graphite, the quality of it, and can it be sourced in Australia?
Yeah, if we've got an hour, I'll give you a lecture on graphite. There are two sorts of graphite. There's the naturally occurring graphite, which is down on the Eyre Peninsula, which is yearly. And that graphite's got a lot of Australia mixed up with it. So when it comes out of the ground, you've got to get all that dirt out. And normal mining processes clean that up. That'll get it up to about 85, maybe 90% clean. To use it in this sort of storage application, it's got to be very, very pure, up to 99%. And so you can clean natural graphite out of the ground using the process that is involved with all of us. And then press that graphite into blocks, and that's one source of graphite. And that's probably the cheapest way of doing it, in fact. The other source of graphite is what they call synthetic graphite, and that's used in industry for the electrodes and electric arc furnaces and so forth. It's all made from synthetic graphite. And synthetic graphite pretty well all comes out of China. This a bit comes out of Russia, a bit comes out of Canada, but mostly, so there's the two entirely different sorts of graphite. At the present moment, we're using Chinese graphite, but as we build the industry up in Australia, we would like to create a graphite industry in Australia. And South Australia's got all of the, pretty well all of the graphite deposits that are in Australia, here in South Australia.
We have another technology which will refine graphite to 99.95% purity or better, with about much greater heat storage density, if you like, than synthetic graphite. It's synthetic graphite is a dirty process. I mean, you get pet coke from the oil industry as a residue, you heat it to 3,000 degrees Celsius over an 11-week period, take it up, hold it, and bring it down. An environmental and power nightmare. Natural graphite you can refine using a chemical process to get to 99.95, but greater density, which gives it great heat storage capacity. And Tesla would say, for example, they've said that I guess if they put natural graphite in their car, go 37% further. So that's a revolution that's sitting out there to come. Other questions? Yes.
Can I just ask, if in these climate change times, if we have a 50-year hailstorm goes through Port Augusta, and as you say, this is 60% of your costs in the mirror itself, what's to stop the natural phenomenon smashing everything you've got?
Yeah, there's a fortunate technical issue here that once you bend the glass, the shiny face is in compression. So you can hit it with a hammer and you won't break it. If you hit it on the back, it'll break because the other side's in tension. That's a bit of engineering stuff. So the hailstorms will not break this glass. It's special glass in here for solar applications. And it's the same glass that's used in all other solar applications, in troughs and big mirrors and so forth. So that's not peculiar to our technology. The resilience of that glass is peculiar to the industry. If for some reason you turn the mirror over, you get a hailstorm and smash the lot. But that doesn't happen, of course, because the control system, as Lyle said, at night time it stands up, and if the winds get above 100 kilometres an hour, they lay down, but always facing potential hailstorms.
Thank you. One other question, I think we've got to do it close. Yes?
The steam conditions I saw it on the data sheet, 400 degrees, I thought, is that correct, or and what sort of pressure?
The steam turbines come in all sorts of shapes and sizes. The turbines that we prefer to use because they're the most efficient operate at 383 degrees. And a 50 megawatt is operates about 80 bar. 80 bar. They are high-end German turbines.
Okay, well, I think it's time to draw the session to a close. So thank you all very much for coming. As Mark mentioned, I've been at this for quite a few years. I did have an environment policy in '93 that nobody bothered to read. They got distracted by the GST or some damn thing. Mark was probably instrumental in all of that. So yeah, we were looking for 20% cut in emissions by 2000 for the 1990 base. But since then, I've been involved in a whole series of businesses that show that you can actually make a quid out of a sensible response to climate change. Whether it's recycling household garbage or energy efficient light bulbs, or we've got the largest biodiesel plant in the world, another company, green data centres doing sugarcane into electricity, whatever it is. This is the best I've seen. And this is a game changer for the industry, and it actually does make solar and potentially wind very successful outcomes, particularly solar. And solar, as was said, South Australia is a solar state. I think it can actually be the solar state with this technology. Thank you very much for coming.